A National Electrical Code, or NEC, requires that a single circuit cannot exceed 80% of the circuit's ampacity. For a 20 amp circuit, this means the maximum load should not exceed 16 amps, calculated as 20 amps multiplied by 0.80, which equals 16 amps. Nonlinear loads, such as computers, generate harmonics that can distort the current waveform and increase the effective current draw. The NEC recommends using a harmonic factor of 1.25 for computers to account for the additional current due to harmonics. To determine the maximum number of computers on a single 20 amp circuit, firstly, estimate the load of each computer. Without nameplate data, a reasonable estimate is 1 amp per computer. Secondly, multiply the estimated load by the number of computers to get the total load, which is 1 amp per computer multiplied by 10 computers, equaling 10 amps. Thirdly, apply the harmonic factor, which is 10 amps multiplied by a 1.25 harmonic factor, equaling 12.5 amps. Fourthly, compare the total load to the circuit ampacity, which is 12.5 amps compared to 16 amps, which is 80% of 20 amps. Based on these calculations, you can place a maximum of 10 computers on a 20 amp circuit while remaining in compliance with the NEC and accounting for harmonics. It is important to note that this is an estimate, and actual loads may vary. It is always best to consult with a qualified electrician to verify the actual load and ensure compliance with all applicable codes and regulations. Factors that can influence the actual load of a computer include the power supply efficiency, the type of components used, and the usage patterns of the computer. Power supply efficiency refers to how well the power supply converts alternating current, or AC, power from the wall outlet into direct current, or DC, power that the computer's components use. A more efficient power supply will draw less power from the wall outlet to deliver the same amount of power to the computer. The type of components used in the computer can also affect its power consumption. For example, a computer with a high-performance graphics card will typically draw more power than a computer with an integrated graphics card. The usage patterns of the computer can also affect its power consumption. For example, a computer that is used for gaming or video editing will typically draw more power than a computer that is used for word processing or web browsing. Therefore, it is important to consider all of these factors when estimating the load of a computer. In addition to the harmonic factor, there are other factors that can affect the current draw of a computer. These factors include the voltage of the power supply, the power factor of the power supply, and the ambient temperature. The voltage of the power supply refers to the voltage at which the power supply operates. In the United States, most power supplies operate at 120 volts or 240 volts. The power factor of the power supply refers to the ratio of real power to apparent power. Real power is the power that is actually used by the computer, while apparent power is the product of the voltage and current. A power supply with a higher power factor will draw less current from the wall outlet to deliver the same amount of real power to the computer. The ambient temperature can also affect the current draw of a computer. As the ambient temperature increases, the components in the computer will become hotter, which can increase their power consumption. Therefore, it is important to keep the computer in a well-ventilated area to prevent it from overheating. When installing computers on a 20 amp circuit, it is also important to consider the other loads that are connected to the circuit. Other loads can include lights, printers, and other electronic devices. The total load on the circuit should not exceed 80% of the circuit's ampacity, which is 16 amps for a 20 amp circuit. If the total load exceeds 16 amps, the circuit breaker may trip, which will interrupt power to the computers. To prevent the circuit breaker from tripping, it may be necessary to install a separate circuit for the computers. When installing a separate circuit for the computers, it is important to use the correct size wire and circuit breaker. The wire size should be large enough to carry the expected load without overheating. The circuit breaker should be sized to protect the wire from overcurrent. It is also important to use the correct type of receptacle for the computers. The receptacles should be rated for the voltage and current that the computers will draw. In addition to the NEC, there may be other local codes and regulations that apply to the installation of computers. It is important to check with the local building department to determine the applicable codes and regulations. Finally, it is important to have a qualified electrician inspect the installation to ensure that it is safe and compliant with all applicable codes and regulations. A qualified electrician can also help to determine the actual load of the computers and ensure that the circuit is properly sized. When calculating the number of computers that can be placed on a 20 amp circuit, it is crucial to adhere to the NEC guidelines and account for harmonic currents. Harmonics are generated by nonlinear loads like computers and can significantly increase the current flowing through the circuit, potentially overloading it and causing overheating or even fires. The NEC mandates that circuits should not be loaded to more than 80% of their rated ampacity. For a 20 amp circuit, this means the maximum continuous load should not exceed 16 amps. When dealing with computer loads, the NEC recommends applying a harmonic factor to account for the additional current caused by these distortions. A common harmonic factor used for computers is 1.25. To determine the maximum number of computers that can be safely connected to a 20 amp circuit, firstly, estimate the current draw of each computer. Since nameplate data is unavailable, a reasonable assumption would be around 1 amp per computer. This estimation should include the computer itself and any essential peripherals directly powered by it. Secondly, multiply the estimated current draw per computer by the number of computers to find the total current draw before considering harmonics. If you plan to connect 10 computers, the total current would be 10 amps. Thirdly, apply the harmonic factor to the total current draw. Multiply the 10 amps by the harmonic factor of 1.25, resulting in 12.5 amps. Fourthly, compare the adjusted total current draw with the 80% ampacity limit of the circuit. In this case, 12.5 amps is less than the 16 amp limit, suggesting that 10 computers could be safely connected. However, it is crucial to understand that these calculations are based on estimations. The actual current draw of computers can vary depending on factors such as the specific model, usage patterns, and the efficiency of the power supplies. Therefore, it is essential to verify these assumptions with accurate measurements. A clamp meter can be used to measure the actual current draw of a representative sample of computers under typical operating conditions. This measurement should be taken over a period of time to capture fluctuations in the load. If the measured current draw is significantly higher than the initial estimate, the number of computers connected to the circuit should be reduced accordingly. Another important consideration is the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a long circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can also increase energy consumption. The NEC specifies the maximum allowable voltage drop for branch circuits. To minimize voltage drop, use the correct wire size for the circuit. Larger wire sizes have lower resistance and will result in less voltage drop. The length of the circuit should also be kept as short as possible. In addition to the NEC, local codes and regulations may also apply to the installation of computer equipment. It is important to check with the local building department to ensure compliance with all applicable codes and regulations. Finally, it is highly recommended to consult with a qualified electrician to ensure that the installation is safe and compliant. An electrician can perform a load calculation to determine the actual load on the circuit and can also verify that the wiring and circuit breaker are properly sized. The electrician can also identify any potential hazards and make recommendations for improving the safety and reliability of the electrical system. When installing a large number of computers, it is often more cost-effective to install a separate circuit dedicated to the computers. This will ensure that the computers have sufficient power and will also prevent overloading of existing circuits. A dedicated circuit should be sized according to the total load of the computers, plus a safety margin. The circuit should also be protected by a circuit breaker that is sized appropriately for the wire size and the expected load. In addition to the electrical considerations, there are also several safety precautions that should be taken when installing computer equipment. Firstly, always disconnect power to the circuit before working on any electrical wiring. Secondly, use appropriate personal protective equipment, such as gloves and safety glasses. Thirdly, follow all manufacturer's instructions for installing and connecting the computer equipment. Fourthly, inspect all wiring and connections for damage before energizing the circuit. Fifthly, test the circuit after installation to ensure that it is working properly. By following these guidelines, you can ensure that the installation of computer equipment is safe and compliant with all applicable codes and regulations. Remember, safety should always be the top priority when working with electricity. In summary, when planning the electrical infrastructure for a school computer lab, several factors need careful consideration to ensure safety, compliance with the NEC, and optimal performance. Firstly, accurate load estimation is essential. While an initial estimate of 1 amp per computer might seem reasonable, it's crucial to measure the actual current draw of the specific computers under typical operating conditions. This measurement should include all connected peripherals. Secondly, harmonic currents, generated by the nonlinear nature of computer power supplies, significantly impact the overall current draw. Applying a harmonic factor of 1.25, as recommended by the NEC, accounts for this additional load. Thirdly, the NEC 80% rule dictates that a circuit's continuous load should not exceed 80% of its rated ampacity. For a 20 amp circuit, this limit is 16 amps. All load calculations must adhere to this rule. Fourthly, voltage drop along the circuit can affect equipment performance and efficiency. Minimizing voltage drop requires using appropriately sized wiring and keeping circuit lengths as short as possible. Fifthly, local electrical codes and regulations may impose additional requirements beyond the NEC. Consulting with the local building department ensures compliance. Sixthly, engaging a qualified electrician is highly recommended. They can perform accurate load calculations, verify wiring and circuit breaker sizes, identify potential hazards, and ensure overall safety and compliance. Seventhly, consider dedicated circuits for computer labs. Installing a separate circuit solely for the computers prevents overloading existing circuits and ensures a stable power supply. Eighthly, safety precautions are paramount when working with electricity. Always disconnect power before working on wiring, use appropriate personal protective equipment, and follow manufacturer's instructions. Ninthly, proper grounding is essential for safety. Ensure that all computers and peripherals are properly grounded to prevent electrical shock hazards. Tenthly, regular inspections and maintenance are crucial. Periodically inspect wiring, connections, and circuit breakers for any signs of damage or deterioration. In addition, consider using energy-efficient power supplies and computers to reduce overall power consumption and minimize harmonic distortion. Educate users about energy-saving practices such as turning off computers when not in use. Properly designed and maintained electrical infrastructure is essential for a safe and efficient computer lab. By carefully considering all of the factors outlined above, you can ensure that the electrical system meets the needs of the computers while also protecting the safety of the students and staff. Remember, when in doubt, always consult with a qualified electrician.